So, dear participants, good afternoon to all of you. So, today, really a wonderful day to NIT Calicut. So, we have the honorable speaker of the today program, Mr. Christo George, who is very known, well known, not only in Kerala, throughout our country, as an successful entrepreneur, who an engineer finally become an entrepreneur, and he has lot of hurdles, and finally he succeeded to launch his industry. And today he is, if you count a leading industry in India, I am sure that his company will be one among that. So let me introduce formally our speaker of the day today. I hope this is the first industrial session we are arranging in the past 2 days. This is the first session. So Dr. Christo George is an engineer, graduated from VLB Janaki Ammal College of Engineering, Coimbatore. So currently he is the chairman and managing director of Hykon India Limited. So as I mentioned, after graduation, he never wait for the opportunity. In fact, he himself created an opportunity. So he started a startup company named as Hykon India Private Limited with 5 employees. After a lot of hard works and trial and errors, he finally established, with his 29 years of experience, he established the very big company, Hykon India Limited, with a current employee of 45, with 5 branches, not only in Kerala, throughout the country. So Mr. George is the managing director of Crops India Private Limited. Also, he is the founder of Max Value Credits and Investments India. So he has won the prestigious national award from the Honorable President of India, the Rashtriya Ratan for outstanding individual achievements and service, Kamal Patra Award for outstanding achievements in business, Kerala State Productivity Award for service industry. He has won Best Entrepreneur Award during the year 2004, 6, 8, 2009 and 2009. In January 2021, Hykon's 5th manufacturing unit started production of e-auto rickshaws, which is powered by Hykon own manufactured lithium ion battery. As I mentioned in the beginning, today I hope it's a great opportunity for the participants to personally talk to Mr. Christo George sir. I know him personally for the past more than 10 years. We are having some interaction. So please make this opportunity as a great one, and see that you are enlightening. I think the session is more useful, especially in terms of research. So the platform is yours, sir. I welcome you on behalf of our FDP, on behalf of the participants, and my own behalf. Hearty welcome, sir.
Okay, just 1 minute. Sorry, I think the internet was. Is it visible now?
Yeah, it is coming, sir. It is coming.
Okay, thank you. So, Dr. Kumaravel and dear participants, very good afternoon to all of you. One thing we should understand is that we are going, one of the biggest disruption in this century will be happening in 2 areas. One is in transportation and another is in energy sector. When we say transportation, for the last 100 years, we are having the same method of transportation using the IC engines, internal combustion engines. And if you look back, it has been disrupted from the horse carriages to transportation almost 100 years back. And we have the same technology almost for the last 100 years. That is the same IC engines, but the technology has been advanced in IC engines. But we are using the same battery, this lead acid battery, for the last 100 years. The same lead acid battery with the change in technologies, advancements, we are using the same. But in 2 sectors, this IC engine is going to disrupt because of electric motors and electric vehicles. and we will think that it may take another 10 to 15 years. But in reality, switching may happen as it happened in mobile phones. It will come like a tsunami. When mobile phones started, everybody who are manufacturing landline phones thought that it will take it to reach to the take a very short time only. Like that, to be, this electric vehicle will disrupt the conventional IC engines in a very short period. Similarly, it will also because the technology of battery is there for the last 100 years. Now, with the new technology or batteries getting disrupted because of the technology what is available. The cost of both, the battery is coming down. Once the cost of battery comes down, the cost of electric vehicle will come down. So it is going to come like a tsunami in the near future because it will the mass once the cost at par with the conventional vehicles. So here the importance of lithium battery in electric vehicles and what are the types of battery available and the parts of lithium battery and what is the technology used now. So these are all covered in this session today, and we'll have a question and answer session in the last. We'll give a 20 to 30 minutes for that. So we'll start with the lithium battery. Next slide. So if you look at the electric vehicle segments right now in India, it has started with two-wheelers almost 10 years back. And in two-wheelers, can see from two-wheelers smaller version, it was started with a vehicle with 30 kilometers speed or 25 kilometers speed, which doesn't require any license to drive and no need for a registration. So it is a small vehicle and it was launched with a lead acid battery and it became a failure in India because of charging problems and the kilometer run per charge and the life of the battery all affected. Now it has been moved from lead acid to lithium, and normally the battery capacity what we use in these vehicles are voltages from 24 volt to 72 volt. Small vehicles will have 24 volt, but bigger vehicles will have 72, like bike, which have high power motors, even up to 3 watt motors they use some of the bikes. So watts to 4 kilowatt in bike. Another area which is very successful in India, more than 10 lakh e-rickshaws are working or running in the India in the last 10 years. Now the license has been put down into that sector, regulation has been brought down. Earlier there was no regulation for electric rickshaw. Now it is moving to auto rickshaw, which is we are all familiar. So it is that range starts from 48 volt to 72 volt, and the battery capacity normally from to 10 kilowatts. Next segment is getting launched is the electric cars, where the voltage range is from 160 volt to 540 volt. The battery capacity varies from 30 kilowatt to 150 kilometers, depends the kilometer run in per charge. And we have buses also, which is a very high DC voltage, which covers up to 540 volt to 650 volt, and the capacity is 100 kilowatt to 600 kilowatt of battery in one vehicle. So these are the range of voltage and what is currently happening in India. And we have another sector which is very much important. It is getting, it's called, next slide, we'll go to the next slide. That is the battery voltage range from 24 volt to 48. That is, you can see the buggies and which is used in resorts and golf carts. These two are already there in the past 10 to 15 years. They use lead acid batteries, which they convert now to lithium in a big way. Another two areas is the third picture you see is a automatic guided vehicles, which is getting popular without any manned, it can program, and it can take materials from store to the machinery where in a factory, big factory, the and finished, semi-finished products can carry by this AGVs. They use batteries also, and forklifts. That is another range of equipments use batteries. These are all in the range of 24 volt to 48 volt, and the battery capacity normally comes with depends on different vehicles is 2 kilowatt to 20 kilowatt. So there are various requirements come for battery. When we look at the voltage range is different, the kilowatt requirement is totally different. This all depends on application. So if you look at a battery, the major parts of a LFP battery pack, if you look at it, it contains, one is the lithium cells, which is the most important part. We can call it a heart of the lithium battery pack. It's lithium cells. Then comes the BMS, battery management system. This is a power electronic. There will be a control, and there will be a switching area which controls the DC according to the power of the motor. This BMS has to be designed, how much current has to be done. So a lot of features is included in the BMS to protect the cells of the battery. Third part of the battery pack is the enclosure of the battery. It's also very important and critical when you design a battery, what kind of enclosure we have to use. And fourth part consists of connectors. Here, not familiar here because we are talking about a very huge currents at a high volt of DC, which is not very familiar for the industries. We are talking about 500 volt DC with 300 amps. So it's a very coming up in this industry right now. If you look at the different types of lithium batteries, what we have right now is we have lithium iron phosphate. That is, we are talking about a different type of chemistry which is used in lithium. And we'll explain about each chemistry, what is the advantage, what are the disadvantages. So we'll start with the lithium iron phosphate. There is the lithium manganese oxide, lithium nickel manganese cobalt oxide, lithium cobalt oxide, lithium titanic oxide, and lithium nickel cobalt aluminum oxide. So there will be a confusion which battery we should choose. For that, different application needs different requirement of lithium cells. So we should understand each one, what is the advantage and disadvantage. So we'll go to the next slide. This is a lithium chemistry. What we see is here. One is lithium. We have taken the most popular cells available in India is lithium iron phosphate, lithium manganese oxide, and lithium nickel. We called NMC. First one, in short form, it is called LFP abbreviation, and second one is called LMO, and third one is NMC. These are the general words they use for these cells in India right now. The voltage, if you look at, each one is having its own voltage, like lithium iron phosphate, LFP is having 3.2 volt, and LMO is 3.7, and cell. Major difference to choose these cells is the specific energy. That is the capacity, which can how much energy can hold in 1 kg. If you look at LFP, it is only 90 to 120 watt hour per kg. That is a very low density compared to NMC, where it is coming to 150 to 220. So one advantage or disadvantage here for lithium is that lithium LFP is still compared to NMC. And second, important three parameters for a charge rate, we call the C rate of the each battery. 0.5 to 1C, we'll discuss what is this 0.5 and 1C, and different rating is there for different battery. Similarly, the discharge rate is also different for different applications. And battery, how long this battery will have a life. Normally people will ask whether it will get to 5 years of life, 10 years of life. It all depends. One cycle means one full charge and one discharge. It's called one cycle. Normally this battery, is a LFP battery, will have 1500 to 2500 cycles. So it's have a long life or a number of cycles. LMO batteries life cycle is only, that means if you charge battery and discharge on every day, maximum it can get 700 days of life. And NMC cells have 1000 to 1200. The important is for a time you can set a temperature of 270 inside, so it's almost same. The temperature coefficient for LFP is not mentioned here. They actually wide temperature range. LFP is having advantage for a wide temperature range. We'll explain the next slide of LFP, which is having size of battery made. So it is ideally used for EV vehicles where the space requirement is not a constraint. Then that is the ideal choice. And this is mainly for solar, UPS, because it's stationary, it can consume some space. But LMO, it is used, it need a heavy current for a short period. It can be used handheld like drills, handheld drills and many other medical devices it can be used. So different application we have mentioned. E-bike, bike will have a constraint of space for putting up bigger battery. So we have to choose for bike a smaller space occupying batteries like NMC. So NMC is mainly used for bikes as well as EV. If you long distance designed car, is better to go for a NMC cells because it takes the safety. Lithium ion is one of the safest battery. Even if you put a nail into it, if you cut it, it will not burst. All other batteries, it will burn. So in safe side, LFP battery is one of the best in safety point of view. Even if you are discharging the battery, normal battery, the voltage will drop. If you discharge by 50, will drop by lithium. The great advantage is that even if you discharge to 80%, the voltage of battery will remain safe. So for a small bike, even if you are discharging, normally what will happen when you discharge the battery, the speed of the vehicle will come down because the voltage will come down. So the speed of the if you are using a lead acid battery, but in lithium, it will remain same even after 80% of the use of battery. The voltage remains same. So speed and pickup, everything, torque, everything will remain the same. That is a great advantage of lithium batteries. We'll go to the next slide. So if you look at if you make like this, the most important 5 parameters of a battery is specific energy, specific power, safety, performance, lifespan, cost. Application, you can choose different batteries. If your concern is the safety is the most important concern, then you have to choose a battery which is having high safety. Here, NMC, you can use, the cost is almost reasonable, but specific energy is more. That is the highest in it. But when it comes, the number of cycles is less. So depend which battery for which application it has to be seen. But if you take LFP, we use LFP battery for our electric vehicle, which we are going to launch now for 3-wheelers. We have chose LFP only because of 2 reasons. One is safety is one of the highest. Even if you are an accident, if you cut the battery or cell, it will not burn. Second, the lifespan. We need for a 3-wheeler who are investing on electric vehicle need a long life for the battery. So their concern is when it has to be getting replaced after 5 years or running around 1.5 lakh kilometers, then life is very important. So we choose according to the requirement of the customer or end user, which is most important parameter. So accordingly, we choose that battery because the life is very high for a lithium battery, lithium LFP battery, and safety is high. But specific energy in LFP battery is less than NMC. That means the size, if you have space for battery in a vehicle, the LFP battery need almost 30% of 40% more space than NMC cells because the energy, specific energy in a battery is much less in the same volume. So the volume will be more, the weight will be more. That is one disadvantage. But normally electric vehicle which is not constrained can have this LFP. And LMO is not getting that popular, but it's having a high cost and it is used for a different application where you need a very short uh, power from a like power tools, handheld power tools. It should be light and it can have a very high energy for a short period. So these are the different parameters which you need to look into when you design a battery pack. First, you have to choose which cells I have to go for. And here one point we have left out is the next, if you can go that. This slide have some mistake in the first. Next slide, just we'll go to the next slide. Danger for thermal runaway fire. It does not have any danger for LFP, but normally all other cells is very critical. So when we go to testing our approvals, LFP cells will have a penetration test in ARI or ICAT. They will test each one cell to check whether it will burst or not. That test is called penetration test. That is putting a nail into the battery and to see whether it will burst or not. But that test is not doing for other cells because it will burst. And toxic elements and landfill safety, I think there's a mistake written there. It's all is safe. There's no confusion. All lithium will have the same parameters. It's not only here the important you have to look at is the cycle life. Cycle life LFP is very high, 2,500 cycles. Even if your depth of discharge is very less, this cycle can go up to 5,000 to 8,000 cycles. It all depends on depth of discharge. We'll explain what is depth of discharge. But LCO, it's only 500 to 1,000 cycles. LMO, 300 to cycles, and new type of chemistry is coming in every day. But these are the very well proven cells available in the market for the last 5 to 10 years now. Some battery require ventilation, some battery does not require ventilation. The reason is that this LFP, the temperature rise in battery when it discharges very high current is less because the internal resistance is less for that LFP. Cooling is not critical, but all other batteries in lithium is need cooling, or you cannot discharge a very high current to that. So cooling equipments and requirement is there for other than LFP batteries. And one advantage of LFP is the temperature. It can withstand high temperature. It can withstand from very low temperature to very high temperature, which normally other cells is not. The degradation will happen because in India, you can in normal temperature may reach up to 45 degree in Delhi. So it is critical at 45 is the ambient temperature. Then when the battery is discharged at high current, another 10 to 15 degree will build up. So we are talking about 60 degree or 65 degree in the inside the battery cabinet. But that is a critical, that is the range maximum you can have for LFP. But the range for other cells is very critical. You cannot withstand more than 40 degree inside the battery. That's why in other European countries, NMC cells are more popular because the ambient temperature is much less than in India. In India, LFP is getting more popular because it can withstand high temperatures. Next. So if you look at a comparison chart of this, we have lead acid battery, which is very common everywhere for UPS, inverters and all. We have a lead acid battery. Then nickel cadmium, which is used for refinery or switchgear, and cadmium where it require a very long life, 10 years life, and nickel methane. And then we have a different chemistry of lithium ion. The specific energy, if it is 30 to 50 for lead acid, it means that if we have a lead acid of 100 H battery in other lithium battery, you can see the specific energy per kg is much. So it's almost half. If a 100 kg battery is having 50 kg of weight, the same lithium battery of 100 H will have only 50, instead of 50, half of it, that is 25 kg. So 50% the weight will come down, as well as 1/3 of the size will also come down in lithium battery. So the size and weight will come down compared to lead acid battery. And if you look at internal resistance is very low for LFP. That's why that cells are not getting heated up when heavy current flows. Normally, other lithium batteries, the internal resistance is higher than lithium phosphate, so the heating will be more. Another life cycle, if you look at lead acid, at 80% depth of discharge, there is cycle, you'll get 200 to 300. Nickel cadmium, it will get up to 1000. But if you look at other than manganese, if you look at LFP and other, it will get up to 1000 to 2500 cycles. Next is very important for EV because the charge time, that is once discharged, how much time it can charge it. Normal lead acid battery can charge in 8 to 10 hours or 8 to 16 hours. That is the minimum requirement of time. You cannot do a fast charging for a lead acid battery because the life of the battery will come down. Nickel can be done at a higher fast charging, but the life of the batteries also. But the great advantage for lithium batteries is that charging time can be brought down. Only thing you have to monitor the temperature inside the cells and inside the cabinet. If that is not rising, you can charge even at less than 1 hour, even at half an hour. For that, if you are a very good charger with monitoring all parameters of battery current and all, you can intermittent charge a lithium battery at a higher current, even at 2C, and make sure that the temperature is not rising so that the battery can be fully charged in less than 1 hour. So the self-discharge is also very less in lithium-ion batteries. One great advantage for lithium batteries is that compared to other lead acid and it requires trickle charge to maintain because the charge drop will happen if it is in stationary condition. But lithium, there's no need for a trickle charge. It is once full, it can be switched off the charging. So saving of energy will be there compared to lead acid and other batteries for lithium. Next slide we can go is another important when you design it, you have to take the parameter because each battery will have each cell will have different designing of the battery pack. All depends on the cell what you choose. If you look at the lead acid, 2-volt cells, it's a 2 volt. So, but nickel cadmium is having only 1.2 volt. So if you want 12 volt, you need 6 cells of lead acid battery. You need more number of cells in nickel cadmium. Like that in cobalt, it's 3.6 volt, and manganese is 3.7, and LFP it's 3.2. That is having different chemistry, have different voltages. So you have to take care of that when you design a battery. I'm not going in detail about that. Here the peak load current, what it means. If you are using a battery in a car for starting an IC engine, it need around, if it's a sedan car, it will take 200 amps to initial for 3 to 4 seconds. A 12 volt, they use around, if it's a 100 Ah battery, you need 2C, that is 2 times. If you use a 50 Ah battery, you need almost 5 times of that is called a 5C peak for a short period, for a few seconds. You can take it from lead acid battery. So that is the peak, very high than the, not a peak, but if you look at a continuous discharge, which normally in lead acid it is not possible. It can discharge continuously to a maximum of 0.2 to 0.3. But in lithium, you can continuously discharge. Depends on different type of chemistry, and it depends on different type of, in the same chemistry, you can have cells of different C rating, but you can go very high discharge of batteries. That is even 10C. That means if it's a 100 Ah battery, you can discharge 1,000 ampere from that cell or from that battery when we are talking about a 10C battery. The change in temperature, that is also important. It's very critical. If it is below 20 degree, the lead, the maximum temperature can withstand is 50 or even 60, 70. It can work very well lead acid battery. That is a great advantage. But lithium, normally it is critical. The working temperature is called 0 degree to 45 degree. Now it can withstand a minus 52, minus 20 to 60 temperature. That is for charging and discharging, we have different temperature here. But one great advantage is that in a very snowy country where the temperature is going below 20, lithium can work much better than lead acid battery. Next. So you can see the development happened from lead acid battery. It is there for this very long period from late 1800. You are using lead acid battery. Nickel cadmium, the progress has happened in different years, and lithium is coming to picture for the last maybe 25 to 30. Now it is getting mass production for the last 5 to 10 years. And if you look at maintenance, is a very critical first point. It's lead acid require very high maintenance. Lithium ion doesn't require any maintenance, and safety requirement, thermally safe, stable even at a high temperature. Lead acid battery will not get anything, but the protection circuit is very critical in lithium ion battery. That's why the power electronics is there in BMS, and lot of control circuits, sensitive circuits should be there in the BMS. And if you look at the cost right now, the lead acid battery is very low. Nickel cadmium now is at par with lithium ion battery now, because the cost of lithium battery every year is dropping. It is dropping by 10% for the last 5 years every year. So if it is going like this, by next 2 years, lithium battery cost will be at par with lead acid battery. Then there is a huge replacement will happen in the lead acid field, because it's disrupt that segment of battery which is manufacturing lead acid battery may disrupt in the next 3 to 4 years. Now, if you come to the cells, now we are talking about different types of chemistry which we are used in the cells. Now, the shape of the cells also very critical, which you choose according to your applications. We have cylindrical cells from 18 mm dia to 32 mm dia, different size, like our penthouse cells is coming different. We call it a cylindrical cell. Type of cell is pouch. When you charge, this pouch will little expand. So that is a pouch battery. It has its own advantage, because the moment inside will be there for when you charge, the expansion will be there for the cells. Then we have prismatic cells that is used for higher edge battery applications, which is more stable now, which is easy to pack. And so according to the need of the size of the battery and the edge of the battery and voltage, if it is LFP, all will have the same voltage, whether it is cylinder, whether it is pouch. the cell voltage will remain the same in the same chemistry, but you have different shape. If you need a power tool is should be very handy, very small, then you can use the small cylindrical cell like our pentorch battery. But if you are using for a EV, you can go for prismatic. The number of connections will come down. One single cell of prismatic can go up to 250 H. So the voltage will be 3.2. Then we will have a 250 H battery. But this small cylindrical cell, the H will be only 1 H or 2 H. So if you want 200 H, you have to use small cylinder of 100 numbers. Then interconnections become a problem. You have to be very careful when connecting cells in series and parallel. Yes. Next part, major part is called a BMS. This battery management system. The main purpose of this cell is that when to protect the cell, because each cell will have a small difference in their internal resistance. So when you charge a number of 100 numbers of cells in series, some of them will have low internal resistance so that it will get more charge in short time. So it has to sense the each voltage in each cells, and it has, if the some cells is fast charging, it has to discharge, and we call it balancing the voltage in each cells or strings. So we have to monitor, we have to sense the voltage, and we have to sense the currents. So BMS handles all this. This is and it will have protection to each cells should not go specific voltage and should not come down specific voltage. We call it under voltage or voltage or current, short circuit. All are protected by this power electronic device called BMS. So if there is a battery is getting short, this will have a maximum discharge current will be set inside the BMS so that the BMS will trip so that a short circuit can be protected. And there is a sensors inside the BMS or in the each battery. For the size of the battery will have a number of heating temperature sensors that is sensed to check whether the cell voltage is going up or the string voltage is going up. And if it is going up, the set parameters like 50 degree or 80 degree can switch off the cells from the external device or connected load. So it have protection to protect heating. And this BMS will have a communication which is connected to the vehicle controller. Now all the vehicles are coming with communication. So we'll have a protocol which can communicate communication, which can be monitored remotely also. So these are the major features of the BMS. And here this is a circuit. Using this BMS which is having a motor of 5 kilowatt, it can take current peak power of 10 kilowatt. We are talking a voltage, if it is 48 volt, we are talking about 200 amps current in a short period. So to carry that 200 amps, you need MOSFET and IGBT. So we usually use MOSFET because the voltage is less. Just to control that is to cut off the short at 200, more than 200 amps. So you need a power electronic devices of that capacity. Normally it is done through MOSFETs. So according to the BMS, if you are using a small motor, you need a different, because so the rating BMS depends current rating, maximum discharge happens from the battery. So we have if we are using for a three-wheeler, then it needs a BMS of 50 ampere BMS. The same battery 10 kilowatt, but you can go a 20 ampere BMS if you are using for a solar application. So depending on the application, you have to design the BMS and you have to choose the BMS, because the current is same for BMS rating also. It's very critical. Yes. So the BMS is also come with a communication. We call it CAN bus communication, which is internationally accepted for a vehicle. We use CAN bus communication protocol, and without communication, many of the equipments doesn't need a communication, like auto shower, it need a communication. When you add communication, the cost will go up, everything. But so we have BMS with communication, without communication. Normally, other than EV vehicles, high-end vehicle, cars and buses, small-end vehicles, we use BMS without communication. So we can choose according to the requirement of the end user. Yes. This is a BMS which we are designing in Hykon, our own electric auto. We have a communication embedded in it with BMS with CAN RS 485, RS 232 communication, everything is inbuilt. So this as a module we use for, we made one part separately because this is a control part, and the switching part, number of MOSFETs in parallel. We have a 500 and 1000 amps relays to cut off the battery. That is also requirement of the specification from ARI. So we use relays inside the battery pack. Cheaper, but in our conditions we also two options now, MOSFET as well as relay. So we made a another is switching. We are using this in our electric vehicles. Yes. So it can communicate. If your companies has developed BMS in India with communications, we are one of the companies which have developed the BMS with communication. The data available for which can read from this cell, how many cells totally is the in our battery pack. When we are talking about battery pack in our vehicle, means the cells in series depends on the voltage of the battery pack, because we use LFP cells, so that each cell will have 3.2 volt. So if you use 16 number, so 16 in series, and 100, that is 20 sets you need in parallel. So cells can get module, that data you can take it from that. Number of temperature sensors. Each module will have different temperature sensors placed in the center of the battery, in the bottom of the battery, in the center of the battery. So anywhere any cells is increasing the temperature inside the battery pack. This we can battery voltage, battery charging current through this BMS. Not only it can be controlled also. Yes. And the BMS system, all this state of charge that can be shown remotely through the communication canvas, and state of health and see what is the health of the battery, charging and discharging start. Voltage can monitor, and in the temperature, cell balancing status, everything we want to produce and BMS. Yes. Next. So alerts also available from the BMS. That is, we can set all this low SOC, state of SOH, state of health. So this all we can set in the BMS, so that once the battery of 48 volt, we can set that if it is reached 40 volt, it has to communicate in critical condition. All can set according to the customer requirement. overload current can be over temperature, cell over voltage, cell under voltage, because all there will be each manufacturer will have its own specifications for the cells. So accordingly, we can select and set, and we can get a communication from the BMS to the vehicle. Yes. So the type of communication controls available from the BMS is isolated CAN 2B, that is normally used in the vehicles now. Isolated RS for 85 port is there. Isolated RS 232 port is the external reset. In case the battery gets high current and or gone to a very low voltage, the BMS will cut off. Once it's cut off, you need an external point to reset the battery. Once a cutoff is there inside the BMS, then it need a external to reset. So that can be external reset is possible. Emergency power off, we can make in case any accident comes, trigger this and switch off the entire battery also. Output and on and off battery also possible. You can switch off the battery if you need. Tracking mechanism embedded in the electric vehicle so that we can track the vehicle, and that is used for not for the customer. When its finance is given by the bank, we can track the vehicle, and the finance is not getting, the speed of the vehicle can be controlled from 60 to 20 kilometer per hour. And if again the EMI is not getting paid, it can be brought down to stop. So all this control on and off can be even not only on the vehicle, even on the battery can be controlled now. Yes. Fuel gauge, it shows the SOC of the battery, because it's very critical column meter, we call it. Cannot measure normal battery pack. We can see that when the battery discharge happens, the voltage will drop. But that cannot be applied for a lithium battery, because when the battery discharge happens, the voltage almost remains in same till 80% of that capacity. That means a auto rickshaw which is running, 80% of the discharge of the battery is there, it will show the voltage of initial voltage. So we cannot identify if the battery is full or less. Then next 20% will drop very fast. It's flat till the end and sharp going down. I'll show that curve to you so understand how battery perform. So with just monitoring the voltage of the battery, we cannot identify which state that battery is. So that we have to count how much and how much energy has brought out. So according to that, it shows the percentage of battery. So it's very important when you design a battery pack with monitoring the voltage is not only sufficient, it has to monitor the power went inside and power released from the battery. So that different battery out. Fuel gauge is used to measure the SOC, voltage, discharge current, remaining charge levels. Sometimes this can be fixed on the battery itself, because like lead acid battery, we cannot check voltage and see the battery is full or not. So some customers ask us to fix this fuel gauge in the battery itself. We are providing many customers like that. It is essential for a lithium battery because the voltage will be steady until the 95% power is exhausted. So we cannot status. So the customer can monitor the health of the battery through fuel gauge checked also. Are available in the market. The left hand corner is the how it has sensed. So there will be a shunt which can see, because the 200 amp, 300 amps flowing shunt has to be required. From that it will sense the current, how much current is flowing in to the battery and flowing out from the battery. So the difference will each count will take it and show as the capacity of the battery. Yes. Next is enclosure. When you design a battery pack, it's very important which type of enclosure you need. That depends on which type you are going to put into the enclosure. Because if you see a LFP, it is resistant to temperature, then cooling is not important. But if you are going for a NMC cell, the cooling is very important because the cell has to be maintained at a temperature not more than 40-degree temperature. So accordingly, the chemistry of the cell, you have to design the battery pack, and enclosure is very critical. So different type of done. Next. So battery cooling. The LFP doesn't require a cooling, but maximum you can give a air cooling that is more than sufficient if it is required. High current discharges give a air cooled. Normal LFP batteries is not provided with cooling because it doesn't require. But some of the the battery chemistry, the cooling is critical. So the enclosure has to be designed with either natural cooling or forced cooling. You have to need a blower, like in UPS inverters, you need a blower to cool the MOSFETs and heat sinks. Like in computer also, you are seeing the temperature has to be brought down. So we call it forced cooling. Then even the air is not sufficient because you need a water cooling and oil cooling. The more cooling of the cells, the life of the cell you will get better. If you look at a Tesla car, it is a cooling system is so perfect, the temperature will not rise more than 30 to 40 degree inside the battery pack. So the life of the battery will increase because the life depends on the temperature. So design of the system, design of the battery pack. And recently I seen that in high power bike. So in NMC cell, it become difficult because a 5 kilowatt bike need a high power because 5 kilowatt motor they use in the bike, and it need a very high discharge current for so you have to cool. And the more speed you go, the more discharge from the battery will be high and the temperature will rise. Like in a engine, the temperature rises, battery inside the cells will rise up. So the cooling become. So some of the cases like a engine, you can see the fins, aluminum fins. Like that, the design has been put for batteries also now, so that there will be fins and the air will flow through that fins and the cells inside will cool down. So different type, see, different types of this left side picture is the blower is used to blow the air through that so that it can suck air through that and the hot air will go out. Second one is again aluminum bars are kept inside the cells in that cavity. The cells will be assembled so that the heat will be taken out through aluminum outside the cabinet. So the cabinet itself can make with the aluminum also. Next. Then we have oil cooling because the tubes will be run through the inside the battery and they get cooled. So the different types of cooling is very important for making the. So it all depends on the type you are using. Yes. So the radiator, how the water is cooling the engine. The water is fed through the engine and it is coming back and the radiator will cools down the hot water or coolant. Similarly, there will be a radiator and the battery, there's tubes going through cells and either oil or water will be fed into these tubes and the heated oil will come out and can get cooled down. So and this kind of batteries become very complicated. The cost become critical. That's why in our case, it's very to assemble lead acid. There's a LFP battery. So use in our vehicles LFP battery. And government of India has given most of the specifications given the LFP, asking for LFP, which is one of the safest. Yes. These are batteries what we manufacture for to Gulf cards. minibuses, forklifts, and these are different rating from 100 Ah to 500 Ah. So it's a very big truck. The third picture, if you look at this, is a battery pack which is of around 150 kg. This is used for forklift application. In forklift, the battery weight will come around 1 ton. So that is lead acid battery, and it has to be charged. So they have to take out the battery out with a crane and put it for charging, and another set of battery put again, and that replaces battery, because the weight of the battery depends from 500 or 600 kg to 800 kg in a forklift. Once we replace that battery into that, it's only 150 kg battery. It's very simple. You don't have to take out it. It can be put, because it can be charged in 10 minutes, and whenever the forklift will not work continuously. So the great advantage is that you can have avoid the charging stations like in lead acid batteries. Here you can charge for 10 minutes and it will run for that much of time. So there are a lot of application catching up, converting from lead acid to lithium battery. These are some of the batteries we manufacture also. Yes. These are the bed type batteries which we use for AGVs, and the different application, different size, different shape we use. Yes. This you can see under picture, you can see the fuel gauge, so that the customer can see the fuel gauge, that the state of charge on discharge from that battery itself. We don't have to, because many of the electric equipment, the electric transport vehicles is not having communication and all, and they want to monitor the from the battery itself, the data, and we have battery doctrine, not like the acid battery. So the, all electronics will go in the battery. MS will battery. Yes. Next. Another we discharge, it's called the C rates of battery current rates. So depends on different batteries we have discharge rate. So it's called C20. The lead acid battery available in the market is called, which we use for inverters. We use a C20 battery, which means that at 20 hours, a battery can be discharged fully in 20 hours. So if you put it C10 tubular batteries, mainly for UPS, it says you can discharge that power in 10 hours. But when you go down, 2C means it can discharge 2 times of that battery capacity. If it's a 100 Ah battery, it can discharge 2 times, 200 ampere from that. So from the lead acid battery, there's a limitation, but the lithium ion, there's a high discharge is possible. So that's why lithium is mainly used for electric vehicle system. Next. This is just to, if you take the battery life, normally it will be considered in cycles. LFP, if in EV application, it will have a 2 cycles life. If how it is taking out, we are talking about a discharge and charge. So if you are using a two-wheeler, that battery, and one two-wheeler is running daily full kilometer, that is a two-wheeler is running to 50 kilometers every day. So one cycle is happening 50 kilometer, then their battery come down. So that in a year we are using 300 cycles. That is one day, one cycle means around 360 cycle will come. If you are not using every day, you can take it as 300 cycles an year. That means that battery will last more than 6 years. So from cycles, we are converting into years. How from Nobody tell years in battery specification. They will talk only about cycles. So one cycle is one charge and one discharge. If the same two-wheeler is used only running not every day 50 kilometers, it's running only 20 or 25 kilometers every day. So you need only a discharge will happen fully or 3 cycles in a week. In that case, it will get a 12 years life. Same like in three-wheeler, getting given an example 2000 life cycle is a in three-wheeler. If you are discharging the battery fully, we are talking about one cycle per day. Because in our vehicle, it is having 10 kilowatt battery. In one cycle means we are talking about 200 kilometers can run per day. But normally, auto rickshaw run 100 kilometers average. So even if you are running full battery, we are talking about one cycle per day. So in a year, it may take 300 cycles. So the life may be 6 years. Same in a car. If it is normally house purpose, the discharge battery will not happen every day because the car will be running with less normal use. So if you are considering 2 cycles per a week, then we are talking about 8 years of life. So life depends on the cycles and depends on the cycles you cover in a day or in a week or in a month or in a year. So you'll get an idea how the cycle is getting converted into life. Next. So normally it is a second parameter for affecting the life of the battery is the, we told in cycle is there. Then if you are discharging battery 1C, that is a 100% you are discharging, that is at 1C, your life is getting 2000. That is the cycle they are saying. If your battery is discharged at 1C, you get 2000 cycles. I'm taking now the LFP case. But if you are discharging only 50% of the battery, then the cycle will increase to 5000. So that's why the same battery which we use in EV, if you use for telecom purpose, in telecom, the power failure will happen only once in a month or once in or 3 times in a month. So that cycle minimum you will get a 5000 cycle in that application. So it depends on the depth of discharge. The life of the battery will go up. The cycles will also go up. So if you are having 10% discharge, the life of the battery is very huge. It can go up to many years. But normally we can go up to 20 or 25 years. We still don't know because the time cycle has not reached for that is not very clear, but it can go a very long period. Because of this, like a lead acid battery, we say that after that cycle it becomes a scrap battery. But you can say the depth of discharge, the life will increase. So if a battery is used from the EV battery will get replaced by if the 30 to 40%. Instead of running 100 kilometers, it's only running now up to 60 kilometers, the battery will be removed. That means the capacity of the battery need to have a capacity of 60 H. This 60 H battery can be used for a low discharge cases like it will be discharged only 10 amps out of that if you use for a street light or only 25 amps discharge if you use for a UPS application. So that EV battery can be reused again without any modification, different. So it's called a second life. Then it can be used for UPS application, and it can third life it can be used for very low current applications like street lights and all. So this battery have a long life. So from one cycle it can go one life it can be used for another life for another application. Then from the third life, so the scrap battery will get a better rate after running out its life for that specific application. So the years depends on the depth of discharge. Depth of discharge means how much energy has been discharged from it. So according to the life cycle will increase as well as the years will get maximum. One area to reduce the depth of discharge is double the size of the battery in the vehicle. The cost will go, but the life of the battery will get more. So you have other option to increase the battery capacity to increase the life of any application. Next. Some of the discharge curve, I told the first one, discharge performance are different. C rating. C rating means how much discharge is happening. You can see the voltage in all discharge, whether it is 0.2C, 0.5C, 1C. 1C means if it's a 100 Ah battery, it discharges 100 ampere from that battery till it. So you can see the voltage remains flat. That means the voltage is not dropping like normal lead acid battery. When it is used about 9, it drops. From that, suddenly in 5% balance is there, then only it is dropping. So we have graphs at how it performance at a different discharge rate, how much voltage drop and what is the capacity drop. So the capacity almost it remains same at even at a 5C discharge also. Second one is the discharge performance at a different temperature. I'm talking about this LFP is given a graph of LFP. Even at a 20-degree temperature at 1C, you can see that graph. Which is that top, the 3.2 volt remains same, and you will get almost 100% of the capacity. But the same battery, if you discharge at a minus 60 degree, that is the lowest curve, the voltage you can see the starting at 2.8 or 2.7, and the capacity is showing only 40%. From that, it is dropping faster. So when a battery of 100 Ah battery we use in a place where the temperature is minus 60 degree, or I am talking about 60, yeah, it's a plus 60 degree, the capacity of that battery will drop very much. So the capacity of the battery depends on the temperature. So you will get a more capacity when you are using at a temperature of 40 degree to 50 degree. It will be remain same. So the that black one is lowest curve, that is minus 20 degree. So if you are having a battery of 100 Ah and at minus 20 degree, it will work. That is the most important thing. So it can be used for defense vehicles where the temperature, or in north areas where there is a snow and the temperature is very Arctic region, Arctic vehicles. That acid battery balance below 0 degree or below, you have to heat it up, otherwise it will not work properly. This one, even at a minus 20 degree, the capacity will be only less. That is, it will have 40 H. That is the great advantage of LFP batteries in very low temperature. That's the lifetime performance at a different depth of discharge. You have more cycles when the depth of discharge is like. You can reach number of cycles. First one is showing 0.2C. The cycles you will get more, and the capacity will remain to 80%. That is around more than, here we are talking about 4,000 to 5,000 cycles. This even at 3C, you can see the drop is more, and to 80% at 1,000. That is the last one. Next. This is the combination how a pack can be made. You can, each one is 3.2 volt. That means 4 numbers in series, you will get a 4 into 3.2 volt. That is 12.6 volt you will get. So if the 4 cells are connected in series, you will get a 12.6 volt. And if it is a 5H cell, or if it is a 5H, you are talking about 12 volt, 12.6 volt, 5H. If it is a 10H, you will get the same, can be connected series. Now, how much H you need? This 12 volt, you can add how many in parallel. So it's a series and parallel combination. You can get the voltage of the battery. So need a 3.2 volt into 100 numbers in series. you will get a 320 volt battery. So the advantage here is you can make any combination and go to high voltage of 650 voltage battery with a small cylindrical cell also. It's very critical as the voltage increases, all the thermal protections and easy is very critical. Precaution has to be taken for designing a high DC voltage batteries, which is used in buses and cars. So this is a very brief how you can make a battery packs, different cells using this. I think I have covered most of the areas in the battery, which is used for the industry right now. So thank you very much. If anything is there, you can ask questions. You go to the next slide. It's completed. So,
So, thank you very much, sir, for your enlightened speech, especially in the practical aspect. So, dear participants, it's a time for interaction. So, I request the participants to clarify your queries if you have.
Good afternoon, sir. Hello. I'm Dr. Nanamurthy.
yes, I can hear you.
Hello.
Yes, now I can hear.
So any manufacturing sector available in India for lithium ion batteries, sir?
Lithium ion battery manufacturing, many companies are doing, even we are also doing, but manufacturing of cell is not started happening in India right now. Then small volume, they have test market or test volume has been done. But many companies are going to come up in the manufacturing of cells in India in next 2 to 3 years.
Sorry. Where is the main source of lithium available in the world? So more lithiums
It is available in the European countries like Latin America. Lithium is available, but that is the mined item. In a battery, if you look at it, there's a copper sheet and aluminum sheet on that. There's a coating, lithium coating. That coating consists of, if you take the weight of the battery, that content is only 2% of the battery weight. So it's so negligible lithium content in the battery, and it has been mined, and there are plenty available in this world to continue for the next 500 years the lithium. But the process is happening either in Japan, Korea, and China. That is the major source where the lithium, mined lithium is getting processed and converted into usage of.
Okay, thank you, sir. Thank you a lot.
There are some questions in the chat box.
Can you read out?
Yes, sir. Yes, sir. Can NMC, what is it?
Sir, can I talk, sir? Dr. Kumravil, sir, this is
Please,
Madhuri.
madam. Go ahead, please.
Yes, sir. Hello, sir. This is Dr. Madhuri, sir. Sir, very interesting talk, and I'm very glad to know that we have lithium manufacture. I didn't know about Hykon before, sir, but I'm very glad to know that we have manufacturing here only, sir. Thank you. Sir, there are 2 or 3 questions I have, sir, if you don't mind.
Yes.
Sir, the first thing is the NMC batteries that you have said, sir, in the charging table, you have said only up to 1C, but is it okay to do the fast charging at 2C or more for NMC? Is it safe?
NMC, it's a
Sir, your voice is breaking, sir.
3. Can go to 3C,
3C
no
charge,
problem.
sir.
Only thing the temperature. Yeah, you can charge it faster. Only thing you have to control the temperature and make sure the temperature never rise in the cells. That's all.
Okay, sir, and I also like one or two companies that I have gone, sir. I have seen these your prismatic model of this lithium cell, sir, like in enclosures. So, sir, but if we want to do some kind of like if we want to attach a BMS to that, sir, once we put it in an enclosure, I am not sure. I'm not seen that, sir. So I'm talking from inexperience only. But if we put it in an enclosure, sir, so how do we do is the cell balancing and all still will be accessible for us if the moment we put it in an enclosure?
In the enclosure, when you put it the cells, you'll need a BMS inside. Otherwise, the BMS will sense the. So
Yes, sir, yes, sir.
you want to make a battery, then you have to purchase it. You have to purchase the BMS separately, get it assembled, and the BMS has to kept inside. So the wiring will be from one BMS. How many cells are there? You have to do the wiring for sensing for each point.
Yes, sir. I was looking at more like purchasing these and doing like a small BMS myself. So that's why I was trying to see whether we can access these if we don't, like let's say, buy an integrated BMS. So then, will it be possible for us to kind of have a BMS separately? I mean, that's what was my question. If we purchase from you.
Yeah, you can get the BMS separately. If you want it, we can give and we can support you. No problem.
Okay, sir. And sir, just one more question, sir. Sir, currently, when you're talking about voltage levels for vehicles, when you're supplying, sir, what is for a four-wheeler vehicle? Typically, what level of voltages are the voltage and current rating? I saw in the slide, sir, but can you just elaborate that a little for a four-wheeler?
Four-wheeler, there are different type of four-wheeler, starting from 48 volt to 540 volt. Which segment you are looking at, a car or a
Cars, sir.
four-wheeler?
Cars.
Most of the cars which is coming now is coming with AC motors, which is working from 560 volt DC. So you have to give a battery pack of 560 volt. You have to plan for that high voltage DC. Earlier, the car with 96 volt or 120 volt, but the power is not sufficient. When the power increases, the current increases.
Right,
So
sir.
the loss will be more when you use a low voltage battery, and the BMS, everything has to be very big switching devices. So they increase the voltage, DC voltage to a higher extent that the loss in all areas will come down. So normally now new generation DC voltage.
Okay, so that means if we buy low voltage, then that boost and boost converter sizes and all will become more and unnecessarily it will become lossy. So that is why I think, yes, sir. Thank you so much, sir. Thank you, sir. Those were my questions. Thank you so much.
There's a question for can NMC come 2C charging? Yes, it can do 2C charging, no doubt.
That is a question asked by the present participants.
Yeah.
So there is another question, sir. Is there any wireless chargers have been explored for Hykon EVs?
We want to get a support from NIT for developing the wireless. It's practically using for last 10 years in many other applications. Now mobile phones also becoming wireless charging. It is very much is possible. It can be developed, and that is the instead of a charging station, you park the vehicle and it will get charged. So the design of the vehicle and the battery will become critical, and the distance between it has to be made short. Many customers on AVG, we are talking about AVG, automated guided vehicle, where we are given the battery. They are asking the same question: can they do the wireless charging on that? AVG height is very small, width, and it can carry 1 ton. So we want a support from NIT for developing this wireless charger, high power, not small power.
So thank you, sir. Already we have some collaborative research. Hope that we will succeed. We are also working on this wireless charging. Hope that we will come out with a very good charging at the earliest.
Excellent.
Yeah. So, dear participants, is there any other question? If there is no other question, we can go ahead with the vote of thanks.
Just a question, sir. Is there any research aspect of Hykon is looking in the charging area?
Yeah.
Yes, wireless charging is one area we want. Not only we, almost all EV companies will know more about lithium ion. Thanks for the okay. So that's all the questions I have in the chat box.
Yes, sir. Yes, sir. So from the response, you can understand that they are given very good feedback. I think I know very well that because this is not the first time I am hearing, sir. We have a lot of interactions. I know that you are the apt person to deliver the lecture, especially related to electric vehicle. As I predicted, it's a really great success. So, dear participants, sir is a very polite person. As I told you, you can approach sir at any time. And
Sure.
he is the man who really contributed to the society, not only in terms of electrical. I think his first success was that is a solar water heater. Even now, you can find his solar water heater in most of the hotels. Hykon solar water heater, like a small product he started today. As I said, he is running with more employees. So thank you, sir, for joining with us and accepting our invitation. So really, we extend your support in the near future. Thank you, sir.
I put my mobile number here. If anybody want to contact me directly, you can note down my mobile number 98460 32117. We can support anybody who want to do research on lithium battery. We can support. We can provide all the knowledge because that is a great area where India needs technocrats like you in this area.
Yeah,
So
I
if
think
they want
sir
to,
has shared his number in the WhatsApp groups or in the message group. I think you can feel free to contact sir.
so it's a WhatsApp more than email. I suggest to send in WhatsApp so I can communicate back fast. Email goes to my secretary to the company.